All right, we're looking at ratios of special right triangles again. This time we'll look at a 30, 60, 90 triangle. I'm not going to lay out everything like I did last time, but it's always good to write out and remind yourself. So this is how I always draw it to remember it. It's something that you do have to memorize. All right, do you remember how we label it? I say x, 2x, and radical 3x. Make sure the square root sign's not over the x. The big one's on the bottom. So 60 and 30 here. All right. So then we want to match it to what we have here. All right. So when I match it, we have to define one of the numbers right here. So in this case, the number they gave us matches with which one right here? Well, first we're asked to find the length of side x in simplest radical form with a rational denominator. If there's a square root on the bottom, we have to simplify out of it. All right, so where is this 2 linking to on this one? Well, it's between the 30 and the 90. Between the 30 and the 90 is radical 3x. So that means this 2 is equal to radical 3x. And the way this is kind of written, this x is going to be the same answer as what we have here. We can link it out if when we need to. All right, so this hits a lot of things we need. Good. So to get x by itself, we divide by radical 3. We do to one side, you do the other side, radical 3. All right, so we get x equals 2 over radical 3. Now, this is a really important aspect. We do not have a rational denominator. Rational meaning it's a regular number that is like a fraction or that stops. This is a square root. This goes on forever. So the trick is we have to multiply by exactly the same square root. So we multiply by square root of 3. What you do to one, you have to do to the other, square root of 3. So this is the same thing as 1. I'm not changing it. We don't do it to both sides. That would affect the x. So we do it to top and bottom on this one. And remember, radical times a radical. I'll go ahead and show my work here. So top times top, 2 radical 3. Bottom, radical 3 times radical 3 is radical 3 times 3, or radical 9. I'll use my trick. We have a pair of 3's right there. So this all turns into 2 radical 3 over 3. Notice no more rational or square root sign on the bottom. This is all equal to x. 2 radical 3. Now just be careful. If this were like looking for the hypotenuse, this would just be the x, and I'd have to plug it in to right here and multiply it by 2. But in this case, they're looking for just the 90, between the 90 and the 60 degree. Between the 90 and the 60 degree is just the x by itself. So this is our final answer. And this is kind of as hard as they get. See, on the top is a radical 3. And there it is. Okay. So they're comparing it to the specialized one. I definitely like the generalized one for this. It links together a lot better. Okay. Let's just see. I want to analyze what they're doing using that the singular, the specialized one. All right. So they're saying that the 2. So here's the specific right triangle. It's 30, 60. And the x is equal to 1. X is equal to 1. 1 over 2. So this relationship, 1 over 2, is equal to 1 over square root of 3. Set up a proportion. All right, so they're looking at a single ratio on top of this fraction. So 1 over 2 is comparable or has that same relationship as 1 over radical 3. And let's see. So x is to 1. X is to 1. All right, so I'm just trying to figure out what strategy they're using. So this x links to 1, so they have to draw the specific right triangle. So x is to 1 what 2 is to radical 3. So x over 1 is equal to 2 over radical 3. Is that what they have? x over 1. Nope. So that's one way you can kind of do it. Let's see. Yep, that would give us the same answer. So that's setting up a proportion. Let's try it again. X is to 2. All right, so they like to do it on the same triangle. X is to 2. X is to 2 on this one. So this is our specific. No, this is their problem. So this is the problem triangle. Is proportional to the specific triangle. The specific triangle would be 1 to radical 3. 1 to radical 3. Is that what they have? X over 2 equals 1 to radical 3. All right, so this is how I like to do it. This is comparing triangles. Compare triangles. And this is how Delta Math likes to do it. They like to ratio on same triangle. Ratio on same triangle. All right. And then how I like to do it is I like to compare it to the generalized and solve. All right. So all these methods work. I like showing multiple methods, especially when they're using a particular one. So they're comparing it, the ratio to the same triangle. I'm a big fan of comparing ratios to separate triangles. And for these problems, I like setting it up as a generalized problem, solve for X, and plug it in. All the problems are going to fit under these.